Hi everyone, myself Dr. M. Lakshmi Prasad, working as a professor in the Department of Computer Science and Engineering at Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about implementation of minimum spanning trees. So before going to see that, so what is the spanning tree here? So spanning tree is nothing but a minimum weight spanning tree, so which is going to be constructed from the graph in such a way that all the vertices are going to be visited exactly once. So it is going to connect all the vertices together with the minimum total weights for its edges. And minimum spanning tree is a tree because it is acyclic, and any undirected graph has minimum spanning forest. So it should be the union of minimum spanning trees for its components, connected components. And if the graph is going to have n vertices, then the spanning tree will have n minus 1 edges. So spanning tree and minimum weight spanning tree is the well-connected undirected graph in such a way that you have to visit all the vertices of the graph exactly once. So this is one of the form of the spanning tree, and this is another way of spanning tree like this. And minimum spanning tree should be a tree because it is acyclic. So normally it should be a graph, but it should also become a tree. And any undirected graph has minimum spanning forest should be the union of minimum spanning trees. And if a graph is going to have n vertices, then the spanning tree will have n minus 1 edges. For this graph, so what is the spanning tree here is that, so what is the lines I indicated in edges, so that should becomes the spanning tree of the graph. So this should be the spanning tree of the graph. So from this graph here. So how we're going to construct the spanning tree? So for that we're going to have two kinds of algorithms. So first one is Prim's algorithm and second one is Kruskal's algorithm. So Prim's algorithm is a greedy algorithm that is going to find the spanning tree for a weighted undirected graph, and it is going to find the subset of edges that forms the tree where that should include the vertex, and the total weights of the edges in the tree is going to be minimized. And here the algorithm is going to be operates by building this tree one vertex at a time for an arbitrary starting vertex, and at each steps we're going to be add the cheapest possible connection from the tree to the another vertex. So greedy algorithm is going to find the spanning tree in such a way that we're going to find spanning tree from the weighted and undirected graph, and it is going to find the subset of the edges, so such a way that it is going to be include every vertex where the total weight of all edges of the tree is going to be minimized. And this normally this algorithm is going to be operated by building this tree from one vertex at a time from an arbitrary starting vertex, and each step we are going to add the cheapest possible connection from the tree to the another tree. So what should be the procedure for implementing this algorithm? So initially you have to be minimize the queue to contain all the vertices, and so for this implementation of spanning Prim's algorithm, we need a data structure called queue. So here how the queue is going to be inserted is, so the queue is going to follow la first in first out principle. So what are the item that is inserted in the queue that should be goes out first, and set the key of each vertex to infinity, and the roots key is set to 0 here, and set the parent of the root should be null. And if the weight of the vertex is less than the key value of the vertex, then connect the graph. And repeat this process until all vertices are going to be used here. Okay. So initially minimize the minimum priority queue, so it should able to contain all the vertices of the graph. Set the key of the each vertex to infinity initially, and the root's key is set to be 0. And set the parent of this root should be null. So whenever the weight value of the vertex is less than the key value of the vertex, then repeat the process and connect the graph, then you can able to repeat the process. So this should be the algorithm for implementing this Prim's algorithm. So here I'm going to define the function. So in which the input should be the graph weight and then root here, and initially assign a priority queue which is able to contain all the vertices, and for each vertex of this queue. Okay, so set the key value of each vertex to the infinity. So let us consider the graph, and initially so assign a queue here and then set the key value of each vertex to the infinity here. And next one, so set the root key value should be 0 and set the parent roots should be null. So this should be the initial constraints that is going to be needed to implement Prim's algorithm. So the Prim's algorithm is going to take the input of graph, weight, and then root, and initialize the queue which is going to contain the set of vertices, and set the key of this each vertex to the infinity. Set the root key value should be 0 and parent of the root should be null. So while the queue is not empty here, so repeat the process in such a way that until the queue becomes null. So from this queue extract the minimum value, and for each uh, vertex of this queue which is going to be adjacent, check the value whether there should be uh, the edge value is less than to the top value or not, and set the parent be as visited, and then make this key should be edge of the weight which is going to be connected u1v. So whenever the minimum key value is identified, then you have to mark this edge as the connection. So let us consider an example how we're going to be implement this Prim's algorithm. So for this we are going to have this graph. In this graph I'm going to find this minimum spanning tree, so according to the algorithm. So for running this algorithm, so initially I'm going to be assign infinities to all the vertices, so that should be the initial step. And then I'm going to take one starting vertex, so that should be as marked as 0, so that should be the starting value. And then so black the vertices from the graphs, so whenever it is going to be visited, uh, then so in this one I'm going to select this 3 here. Why? Because this 13 and 14 and 3 among these two, so what is the minimum is 3, so I'm going to select this edge, and from here I'm going to select the next weight, that is 14. So among these two, so 3 is minimum, so I am going to keep this as starting vertex here. So in order to reach this on 1, so what is the vertices that are connected? So that should be 8, and what are the other vertex that is connected? 10. Among these two, so which one is going to be chosen? So the minimum is going to be constant. So I have to mark this as U here. Similarly, from this, so what is the edges that are connected? So that should be 2, 15 and 8. So 8 is already visited. So I have to choose either 2 and 15. So I have to choose 2 is the minimum. So I'm going to make this as U here. And from here, so what is the next minimum? That should be 4, 5 and then 9. So I'm going to choose as 4 as the U. So 4, 5 and 9. So I'm going to select 4 here. So that is going to be selected. So from here, if I'm going to select this, so if the closed loop is going to be optime. So in order to avoid that, I'm going to be neglect this one. So that's why I have to make 9 as the U here. And next one is 15. So that is the only vertex that not yet visited. So I'm going to choose that as the edge. So finally, this should be the spanning tree that is obtained according to the Prim's algorithm, right? So in Prim's algorithm, so how it is going to work, I'm going to explain once again. So according to the algorithm, so first this should be the initial graph and weights are there, and then uh, root is also available. So root should be the initial vertex. So initially I'm going to assign all the values in the queue, and for each vertex of this queue, so I have to make the value should be infinity first. Okay, so once the infinity is made, so I have to take the root key value, and from this I'm going to uh, remove the vertices, black the vertices which is going to be visited. So that is the 3 is the minimum and 14 is the next one. So among these two, 3 is minimum, so that I have to make this as the U here. Okay, so from this, either I can able to select 3 and 10 and 8. Among this 10 and I have to choose 8 here. So I have to make this as U. And next one, so 2 and then 15 is there. So among this 2 and 15, so 2 should be none. So I have to make this as U. And the next one is 4, 5 and 9. So I'm going to select 4, 5, 9. So among these two, 4 is the minimum. So I'm going to select 4 as this visitor vertex. And next one, I'm going to select 5. So, but what happens is that, so if I'm going to select this edge, so the cycle is off time. So that should not be possible here. There should be acyclic right. So that's why I'm going to select 9 is the next minimum. So I'm going to mark this as here, and finally 15 here. So like this, I'm going to consider this spanning tree according to Prim's algorithm, and this should be the final spanning tree. And next algorithm I'm going to discuss is that Kruskal's algorithm. So Kruskal's algorithm is the spanning tree algorithm, which is going to find the edge of least possible weight, so that connects any two trees in the forest. So it should also follows greedy algorithm, and at the same time it is going to be adding according to the greedy algorithm we're going to be add the increasing cost odds at each steps. So this means it is going to find the subset of the edge that forms the tree, so that include every vertex and where the total weight of all edges of the tree should be minimized. So to visit all the nodes with minimum cost without recycle formation. So Kruskal's algorithm, so is the minimum spanning tree algorithm, which is going to find edge of the least possible weight. So that is going to connect any two trees in the forest, and it should be a greedy algorithm, adding increasing cost outside each step. and it is going to find the subset of the edges that includes every vertex, where the total weight of all edges of the tree is going to be minimized. And in order to visit all the nodes at minimal cost, we should not uh, form this cycle. And this is the algorithm we're going to follow here. So in this one, so we need tree edges, vertices, and vertex V is the representation. So initially how to make the tree as null. So for each vertex, so how to make a set, and then we have to be sort all the weights edges in such a way that we are going to arrange all the weights in increasing order. And for each edge in the edge set, we have to find it and have to be add to the tree, and finally applying the union function here. So make a set here and apply the function union, uh, and finally how to be return that. So here for implementing this, I have to need the data structure. Here is that stack. So stack is going to be follow last and first out principle. So whatever the item I'm inserted, that should be goes out last in first out. So what is the item that is last in is 30, so that should be only comes out first. So according to Skulls algorithm, so in the graph, if I'm going to have the weights here, so I have to arrange all the weight in ascending order first. So first one is 5, so I'm sorry 5, that should be BD, the cost is 2, next one is AB 5, and then AC 10. So like this I have to arrange the edges in increasing order first. Then how to make the tree as empty and find how to fill all the edges here. So CD should be 6. So once that is done, so what is the next? So actually I have to make the tree as empty like this, and then I have to choose the next BD and then AB and then AC. And this should not be selected because it is going to form the cycle. So construct the same graph again and then construct the spanning tree according to the Driscoll's algorithm. So for running this algorithm, we have to be first make this tree nodes here. So initially make the tree as empty and make a set of the vertices. And for this increasing order means we have to select the edges in such a way that the minimum is going to be considered first. So among this one, so one is minimum, so I'm going to select this edge first. So among this remaining set of all the edges, so what is the next minimum? Is 2. So that one is going to be selected next. So once that one is done, so what is the next minimum? That should be 5. So 5 is going to be selected first. And next minimum is 8. So that one I'm going to select. The next minimum is 9. So if I'm going to select this, loop is going to be obtained. So not due to that, so I'm not able to select this edge. And next minimum is 13. So I'm going to select this. And next minimum is 14. So I'm going to select this. And what is the next minimum? That should be 17. So if I'm going to select this edge, a loop is obtained. So I'm not able to select this one. And next one is 19. So if I'm going to select 19 also, a loop is going to be obtained. So I'm not going to be select this one also. And next one is 21. So 21 also not maintained. Now 25. So 25 is not going to be connected. So what happens? So what is the minimum? So that should be 20, 25 also. And finally, this should be the spanning tree that is going to be constructed according to the Driscoll's algorithm. Alright, so like this we are going to be construct spanning tree by using these two algorithms here. So what is the spanning tree here? So spanning tree should be a minimum weight spanning tree which is going to be constructed by making use of two algorithms that should be Driscoll's and Prim's. So the spanning tree is going to be constructed in such a way that all the vertices are going to be selected exactly once here by considering the minimum weight. Mainly this one is going to be applicable in traveling salesman problem, like many applications it is going to be used. And the Prim's algorithm and Driscoll's algorithm is going to follow the greedy algorithm all the time to find the minimum spanning tree, and where the sum of the weights of the edges should be minimized in such a way that will have to be selected. And this one is going to be applied by building a tree, and each step you are going to be select the least positive. So for Prim's algorithm, I'm going to use the Q data structure, which should be follows by first in first out principle. And how this one is working here is that initially assign minimum priority Q and set the key of those vertex infinity, and set the parent of the root should be null, and if the weight of the vertex is less than the weight of the key value of the vertex, then connect the graph. And this should be the Prim's algorithm, and this is the problem what I explain according to the algorithm. So in this one, first initially make those vertices should be null, key value should be 0, and find out this minimum set first minimum h that is going to be selected, and from that what is the next minimum weight that is going to be selected, and from that what is the next minimum weight is going to be selected, and from that what is the next minimum weight, that is 4 is selected. So 6 is not going to be selected because of this forming the cycle, and next one is 9 and 15. So but when it comes to the Driscoll's algorithm, so here the Driscoll's algorithm is also going to find the spanning tree. It is also going to be follow greedy algorithm. So all the time we're going to add the edges in increasing cost, and first we have to visit all the nodes with minimal cost without sampling the cycle. And the Driscoll's algorithm here is that so how to be initially make the tree is empty and make the set and apply the union operation and find the set here. So run this algorithm, and from this initially select all the vertices, make this tree as empty and find out the minimum weight, add that h to the corresponding tree, empty tree, and find out the next minimum weight, that is 2 is going to be selected, and next minimum weight is 5, so 5 is going to be selected, and from that next minimum is 9, so 9 is going to 8 is going to be selected, from that 9, so 9 should not be selected because it is going to form the cycle, and 13, and then 14, 17, so 19 is not possible, it is going to form the cycle, and this one is also not going to form the cycle, and this one also form the cycle, so 25 also form the cycle, and this should be the resultant. And how I'm going to find the minimum cost spanning tree means there should be summation of 2 plus 8 plus 14 plus 13 plus 5 plus 1. So 10, 24, 27, 37, 38, and then 40. So this should be the minimum cost spanning tree value. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.